Hello everyone. So today we are going to work on how to maintain the order of this movement and how to make the selected actors move in a coordinated fashion. That means if I ask them to move somewhere like this, they will first they will select each of their destinations based on to make sure that they reach that destination in a minimum time as a group. That would means the furthest point of the destination points will first get the closest character selected from the selected characters, and that character will go there. Like that, in the descending order, the second furthest point will get the second closest character, so they will be moving in the most efficient way, like this. So here you can see their movement. Okay, so that's what we are going to work on. And before we get started, let me remind you that you can download the project files of this project and all other thousands of projects I have done in my channel from the Patreon page. So feel free to check it out. Once you become a member, you can download anything without any limits. And also, this is a part of this strategy real-time strategy game series that I do, so you can watch all other episodes as well. I'll leave the link to the full playlist in the description. And now let's get back to today's episode. Okay, so right now if I select some characters like this and click here, you can see they move to each position, but they can run into each other and there is no coordination between them. So they just randomly choose points they need to move and move there. Sometimes it works, sometimes it's not. So instead of that, I want to have some order. The order that I'm planning to implement is here. If I clicked on some position, furthest location on the grid, the closest character to the furthest location should go there. So instead of going in whatever the way that they come, like right now. So okay, it would be clear when we implement it. So just to see what's going on here, let me go to mode function in the top-down controller. This is where we control this, and here we get the destination grid and ask these characters to go to these locations. That's basically what's happening here. So to clarify their movement, let me add a draw debug line, and starting point would be this actor's location. With actor location. Endpoint would be this destination. I'll draw it in blue. Duration 10 seconds. 5. Right. Now we should see their paths. Yeah, see? Now you see they are crossing each other. There is no, see, no, all of them are crossing. So sometimes it's fine, sometimes it's not. So that's what I want to avoid. Okay, so to fix this, let's go back to out of down controller. Here, I think we need another function to sort our destinations from furthest to closest. So to do that, we would need, well, I don't know, we need to give this, and also we need to give a reference to these selected actors. So this, and then let's collapse to function. Let's call this coordinated move. Okay. Then destinations. In actors. Let's call this in destinations and in actors. Now the first step is here sorting our destinations from furthest to closest. So to do that, we need to have a point that we consider as the current point. So to be accurate, let's run a for each loop and let's get at location. So I need the average of all of these act locations, so the middle point. So let's add a location. Let's make it a vector. So initially this is 0, so I'll add this actor's location and set current location, and then at the end let's again set current location by dividing this. Get the length, get the current location and divide it by this length. So we will get the average of the location of all the given actors. So that means we would have the middle point of all the actors. So I'm going to consider this as the current location in order to calculate the distance to each destination point. Okay, now how do I sort these destinations? So let's get in this. Let's run for each loop. So if I type sort here, you can sort float arrays, integer arrays, name arrays. So, but I can't sort a vector directly. So let's try something like this. Let's get the distance from this to current location. Then I'll add it to a float array. Distance, let's call it. Should be a float and an array. Get okay. Now after adding all of those things, we can sort this dot float array. Okay. Now I have another vector array. Let's promote this to local variable. So we will have array here. Let's call it sorted destinations. Okay, here let's make it descending. So the furthest would be first, closest would be last. Right. Now, if I again run this, the same thing. And here now again I have the distance. We can find this distance here. Find item. Now that wait, find item. We can look for this distance, and this element now will give us in a, if this this element will give us the order for these elements in this in destinations array. So okay, so now I need another this sorted destinations. This should be in the same size as this in destinations. So to make that happen, here in the first try I'll keep adding this. It doesn't really matter if I add it or not. Let's just add it. 0. Okay, and then here now I get an element index, and this size is same as the size of this and this. So sorted destinations, set element, set array element. This is the item, this is the index. Now at the end of this loop we should have a sorted destination array. Okay, now that we have sorted all our destinations, next step is to determine which actor to move to which destination. But before that, just to make sure that we have sorted our destinations correctly, let's again run a for each loop here. And let's debug. Well, no need to do it here. We could do that here as well. So debug. Well, now that I have already added the for loop, let's just do it here. So starting point is this, end point is this, plus let's adjust the height of the line that we draw based on this array index. So if the array index is 0, that would mean that's the furthest point. So shorter the debug line length, further the destination point from the point that we consider. So this we would get a 0 at the beginning. To avoid that, let's make it with the add 1, multiply this with, let's say, 20. Draw here, duration, let's say 10 seconds, thickness 5, and color red. This already, yeah. Play. Okay, so this is the shortest, and so this is the closest, which is the tallest one. Yeah, this is the tallest, this is the shortest, and in this order it becomes. Okay, so I guess it is working. See, This is short, a bit long, longer. I think this is the mid one is the longest, which is closest to this character, the middle point of these characters. Yeah. Okay. I think the sorting is working. Alright, now the next step is actually moving. So for that, this, let's move it here. It is still draw. Still drawing. I just needed this space here to make the movement. So to move, I have this in act. Oh, this should be actors, not actions. So I need to find out the closest character to the destination, and then for the next one I need to find the closest one except the character that we have already commanded for the first point. So we need to do it that way. But to do that, it would be easier if I have a duplicate array that contains all the inactors. So how do we do that? Let's have another local variable command. Oh, this should be a local variable by making it global. Let's call it duplicate. Duplicated inactors. That's clear. And here, as we calculate the middle point, we can get this. Right, now for each destination, now we need to find out the closest actor. So here, let's again run a for each loop, and then we can get actor location, and we can find the distance to this destination. So if this distance is less than whatever the currently closest actor, if we have such a variable, then this would become the new closest actor. So to figure that out, let's add a new variable, actor distance. This doesn't have to be a array. And also closest should be an actor. Okay. Now at the beginning of each loop, I'll set actor distance to something big. Okay. So the reason that I put a bigger value is so we can make sure that it is always the first try when we calculate the distance to certain actor, this will always pass. So if this is less than the current actor distance, then our closest actor would be this guy. The distance would be whatever this value, new actor distance. At the end, we have this closest actor. We can go to function on the closest actor to this destination. And then we can remove this closest actor from this duplicated n actors array, because for the next iteration, when I want to find out who is the closest actor, the actor that we already commanded to move should not be in this array that we consider. So remove it. The reason that I didn't do it in this input array itself is because if I do that, those arrays are passed as references, so therefore at the end, when I do one move, selected actors will be empty. So I will be able to do a move command only once for each selection. Okay, let's see. All right, so they are moving, but still it looks like there's someone moving across, but I think our logic is still correct. The closest actor to the furthest point goes first. That's the logic we used. But to see that here, let's do this row debug line that we did before. If I make it larger a bit, we can study that if it is correct or not. Okay, so here for this point, this guy came, looks correct, because if we consider this, so this would be the furthest point from the middle, and it makes sense for this guy that was here to come here. This is the furthest point, and this guy that was here went there. Well, I think order is correct, but yeah, that is correct. Okay. So here it's clear. So I think we can stop this episode right here. So thanks for watching. As always, updated project files will be available for download in the Patreon page. Link would be in the description below. And if you have any questions, feel free to let me know in the comments. See you in another episode. Goodbye.